Rational exponents. Our first unit this year was rational expressions, and those were expressions where we basically had one polynomial divided by another polynomial. So a rational exponent is basically going to be an exponent that is a fraction. So today we're going to see how to evaluate those. Now, remembering the power law for exponents, so if we have a to the power of m to the power of n, we multiply the two exponents. So suppose that m is equal to 1 over n. So that's our exponent inside. Okay, so the actual exponent on the base of a is 1 over n. So that means the denominator of that exponent is the same as the exponent on the outside. So 1 over n times n would give us n over n, which is 1. So what has happened here, 1 over n multiplied by n, have basically, they've canceled out, and we're just left with the base of a. Now what that means is I can take that expression, so a to the power of 1 over n to the power of n. What I've done here is I've done the nth root on both sides. Now what the nth root means, so if we have the square root, that means n is equal to 2. If we have the cube root, that means that n is equal to 3. So nth root is any number of root that we want. So I've put the nth root on both sides. So the nth root here will cancel out this exponent of n. So over here I have the nth root of a, because I have to do it on both sides. So what I'm left with is just what's inside the brackets here on the left. A to the power of 1 over n is equal to the nth root of a. So whatever the denominator is of that fraction exponent will be the root that we are evaluating. So here's what we're going to do. We want to evaluate these powers, so 64 to the power of half. We could just type that into our calculator, but we want to rewrite it using roots first, and then we can evaluate it from there. So 64 to the power of 1 over 2. So I see that the denominator is 2, which means that I'm going to do the square root. So the square root of 64. Now, we don't write a 2 there for square roots. If we just have the radical sign, it's assumed to be a square root. So the square root of 64 is 8, and that's 64 to the power of a half. Now this one over here, we have negative 27 to the power of 1 over 3. So I see that the denominator is 3. So what I'm doing here is the cube root. So I do have to write a 3 here for cube root of negative 27. Now you may remember that we can't do the square root of a negative number, but we actually can do the cube root of a negative number. Because what we're saying here is we want a number that to the power of 3 will give us negative 27 if we're working backwards. So that works out to be negative 3, because negative 3 to the power of 3 means negative 3 times negative 3 times negative 3, which will give you a negative result. Alright, so what happens if our exponents are in the form m over n? So this means that we don't have a numerator of 1 this time. We have any sort of numerator with a denominator as well. So if I want to evaluate 25 to the power of 3 over 2, I want to rewrite that a little bit so that maybe I can use the same idea that we just did. So what I can actually write this as is 25 to the power of half. Now this we'd be able to figure out using our previous knowledge, but then how can I make that exponent equal to 3 over 2? Now think about the power law in reverse. Okay, so if I want to turn 1 over 2 into 3 over 2, I would have to multiply it by 3, so that means we're going to have an exponent of 3 on the outside. Now at this point, I know that 25 to the power of a half means the square root of 25, and then cubed. So square root of 25 is 5 to the power of 3 is 125. So the trick for this question here was to break up 3 over 2 into 1 over 2 so that we have a numerator of 1 and just a denominator, and then multiply by a whole number for an exponent on the outside. So if you have any exponent m over n, we can rewrite that as the nth root of a of the base, and then with the exponent of m on the outside, or you can write it as the nth root of a to the power of m. So the numerator is the exponent. Now, that exponent can go on the outside of the root or it can go on the inside of the root. It doesn't matter. And just like before, the denominator will be your root. Now, I typically like to go with this one right here, because what's going to happen is we're going to reduce our base first and then make it a little bit bigger because of that exponent. But over here, this base might become very, very large if we do the exponent first before the root. So it doesn't really matter which one you go with, but I tend to prefer this one right here. All right, so if we have 64 to the power of 5 over 2, okay, so just like over here, I know that the denominator here is my root. So I'm going to have the square root of 64. Again, I don't have to put a 2 for square root. And then to the power of 5 on the outside. So I don't have to write it as, just like we did on the last page, I don't have to write it as 64 to the power of half to the power of 5 anymore. You can if you want to, but it's not necessary. So then we just have 8 to the power of 5, which is 32,768. Okay, so again, you could also have, as an alternate solution, you could have the square root of 64 to the power of 5. So you can do the exponent first to the base and then square root it. But if you try to do 64 to the power of 5, that's going to be a very big number and mistakes might happen, okay? But it does still work. You will still get the same answer, but this method is preferred.